Good morning, everyone. Let us continue today's class with transform analysis of LTI systems. So, as we already know that in module number 2, LTI system generally it is a linear time invariant system, as already done in module number 1 in fundamentals of signals, and also in module number 2 where we dealt with linear systems and as well as time invariant systems. So once I talk about this transform analysis, so what needs to be transformed, right? So I have an input signal, say x of n. Okay, now I have this LTI system, so it might be any interconnection of components, and it is y of n, its output. So in z domain, if I want to transform it from the discrete system, okay, so from discrete system to z transform, transforming it to the z domain. Okay, so transforming it to the z domain. So what do I need to do? I need to take the individual z transform of the signals. So looking at the convolution definition, I have y of n, that would be equal to x of n convoluted with h of n. Okay, so y of n would be equal to x of n convoluted with h of n. So from the property itself, it is quite clear that y of z would be equal to x of z. Okay, that is normal multiplication with h of z here. So now what do I need to do? I need to have this function, which is h of n, which is already there in this LTI system, with the input being impulse in nature. So h of n is said to be the impulse response of the system. H of n is said to be the impulse response of the system. Impulse response of the system. Okay, so now if I have h of n to be the impulse response of the system, so what is h of z? So it is nothing but the z transform of h of n. Z transform of h of n. Z transform of h of n. So h of z is said to be the z transform of h of n. So I can write h of z to be the output, that is y of z, divided by the input, that is x of z. So h of z equals y of z divided by x of z. So x of z is said to be non-zero. X of z is said to be a non-zero. So what I can conclude from this is h of z, we know that it is the the ratio of output divided by input. So h of z is said to be the transformation analysis or transform, or we can say that the transform function or the transfer function. Okay, transfer function, or we said to be the system function, or we said to be the system function. Okay, transfer function, or it is said to be the system function here. So h of z is said to be y of z divided by x of z. So transfer function is nothing but h of z here. Okay, so this is the system function or the transfer function. H of z is said to be y of z divided by x of z. Y of z divided by x of z. Okay, so this forms the transfer function or the system function, and it is always valid when x of z is said to be a non-zero function there. So considering a discrete LTI system having an impulse response, say h of n, so we know that y of n would be equal to x of n convoluted with h of n. So y of n here, which will be equal to x of n convoluted with h of n. So there we can generally come across x of n convoluted with h of n. So h of z here would be y of z divided by x of z. So x of z would be, h of z would be the transfer function or the system function. So you have to take the z transform of each and every signal that is there, and later on we can find out the transfer function or the system function. So let us go with the problem to understand quite easily how would it depend. Okay, first one, a causal system, a causal system, a causal system has input x of n has input x of n and output y of n and output y of n. So a causal system has input x of n and output y of n. Find the impulse response of the system. Find the impulse response. Find the impulse response of the system. Impulse response of the system given given okay, given x of n would be equal to delta of n plus 0.25 delta of n minus 1 minus 0.125 delta of n minus 2, and y of n would be delta of n minus 3 by 4 delta of n minus 1. Okay, so this is a given problem where we can generally understand it is a causal system. Okay, it's a causal system where you can have n greater than 0. Okay, greater than or equal to 0 can be considered as a causal system, and an input, say x of n, and an output y of n. Find the impulse response of the system given x of n equals delta of n plus 0.25 delta of n minus 1 minus 0.125 delta of n minus 2, and the output of the system y of n, that would be equal to delta of n minus 3 by 4 delta of n minus 1. Okay, so this is the input. Let me mark, or let me write it as input, and here output would be y of n, what I can write here. Okay, so what is the first thing that you need to do? You have to find the impulse response of the system. You have to find the impulse response, okay, h of n of the system. Impulse response h of n of the system. So to find out h of n of the system, okay, so you may have y of n convoluted with h of n, and then you can find out in like time domain approach. So given this input and output, what you can do, you can apply the z transform first to both input and output. Apply z transform. Apply z transform for both input x of n and output y of transform for both input x of n and output y of n. So in order to find out the impulse response here, so first find out h of z. Later on, from h of z you can find out h of n. What you need to do, you need to take the inverse z transform of it. So h of z, if you apply inverse z transform, you will be getting the impulse response of the system. You will be finding the impulse response of the system. Impulse response of the system. Okay, so this is one thing that I wanted to highlight, the overall procedure in which I can calculate the solution to the given problem, that is x of n and y of n. So let us move ahead with finding out what is x of z. To find x of z first. Okay, so let me write down here x of n to be equal to delta of n plus 1 by 4 delta of n minus 1 minus 1 by 8 delta of n minus 2. Okay, next to find, I'll write it here itself, y of z. Y of n, that would be equal to delta of n minus 3 by 4 delta of n minus 1. Okay, so from x of n you can find out x of z, and from y of n you can find out y of z. So to find x of z here, what you need to do, z transform of x of n has to be found out. Okay, so next what you are going to do, apply z transform to each and everything. So z transform of delta of n. Okay, z transform of delta of n, that would be equal to unity 1 plus 1 by 4 times z power minus 1. Okay, minus, just a moment, minus 1 by 8 z power minus 2. That is x of z. X of z is found to be 1 plus 0.25 z power minus 1 minus 0.125 z power minus 2. Okay, that is x of z here. Next, y of z, that is 1 minus 0.75 z power minus 1. Okay, that is how you can find out what is y of z. 1 minus 0.75 z inverse, that is y of z. Okay, so this is how we can carry out what is x of z, and this is how we can carry out what is y of z. So x of z is found out, y of z is found out. Next, how we are going to take h of z? H of z, that would be y of z divided by x of z. That would be equal to 1 minus 0.75 z inverse divided by 1 plus 0.25 z inverse minus 0.125 z power minus 2. Okay, so that is how we can carry out h of z. Okay, let me write h of z again, as the transfer function. Transfer function, say h of z, that would be equal to what it is, which is 1 minus 3 by 4 z inverse divided by 1 plus 1 by 4 z inverse minus 1 by 8 z power minus 2. So this is h of z. Okay, so I have got h of z. Let me write it in the powers of z rather than z inverse or z power minus 2. What I can do here is I can write 1 minus 0.75 divided by z divided by 1 plus 0.25 divided by z minus 0.125 divided by z squared. That is z minus z squared divided by z squared plus 0.25 z minus 0.125. Z gets cancelled. Okay, z squared minus 0.75 z divided by z squared plus 0.25 z minus 0.125. That is h of z. Okay, that is h of z. Fine. So h of z is known to us, that is z squared minus 0.75 z divided by z squared plus 0.25 z minus 0.125. Okay, so now applying partial fraction method. Applying partial fraction method. Partial fraction method. Okay, yeah. So now what you need to do in order to apply the partial fraction method, h of z divided by z, that would be z minus 0.75 divided by z squared plus 0.25 z, z squared plus 0.25 z minus 0.125. Okay, so I have to resolve this into the constants, that is a and b. A divided by, so just factorize this. What you will be getting? You will be getting z minus, okay, z minus 1 by 4 plus b divided by z minus 1 by 2. Okay, so that's how we are going to get it. I think z minus 1 by 4 plus b divided by z plus 1 by 2, I guess. Okay, so see to it that z squared minus yes, exactly, minus 0.25. Okay, plus 1 by, yeah, you are going to get it correct. So h of z divided by z, that would be equal to z minus 0.75 divided by z squared plus 0.25 z minus 0.125. That would be equal to a times z plus 1 by 2 plus b times z minus 1 by 4 after multiplying divided by z minus 1 by 4 multiplied with z plus 1 by 2. Okay, everything gets cancelled over here, so you will be getting z minus 0.75. That would be equal to a times z plus 1 by 2 plus b times z minus 1 by 4. Okay, So that's how you are going to get this. Okay, so you have to find out a first. That would be z minus 0.75 divided by z plus 1 by 2. That would be z equals 1 by 4. Okay, next, in order to find out b, how we are going to find out b? Z minus 0.75 divided by, okay, so if you want to find out b, okay, so this term has to be equal to 0. So it would be z minus 1 by 4, where z will be equal to minus 1 by 2. Okay, so you can replace the values in order to find out what is a and b. Okay, so after replacing the values, the value of a would be equal to, yeah, the value of a would be equal to 1 by 4, that is point, yeah, so you can write here, which is 1 by 4 0.25 minus 0.75. Okay, that would be divided by 1 by 4 plus 1 by 2, that is 3 by 4. 0.25 minus 0.75, that is minus 1 by 2 divided by 3 by 4. So what it takes? It takes the value of minus, yeah, minus 1 by 2 into 4 divided by 3. Okay, so you are left out with 2 ones are 2 twos are, that is a would be minus 2 by 3. And what would be the value of b? The value of b would be 5 by 3. Okay, a is minus 2 by 3 and b is 5 by 3. So the value of a would be minus 2 by 3. The value of b would be 5 by 3. Okay, so that's how we are going to find out what is the constants a and b. So after finding out the constants a and b, what you are going to do? Z minus 0.75 divided by z squared plus 0.25 z minus 0.75. That would be equal to a, that is minus 2 by 3 divided by, okay, minus 2 by 3, z minus 1 by 4, z minus 1 by 4 plus, what's the value which is written here? B, 5 by 3. 5 by 3, that is z plus 1 by 2, z plus 1 by 2. Okay, so I have resolved it into the partial fraction method by replacing the values of a and b. Okay, so it is again equal to h of z divided by z, that is minus 2 by 3 divided by z minus 1 by 4 plus 5 by 3 divided by z plus 1 by 2. Okay, so next what you are going to do? H of z, that would be equal to minus 2 by 3 z divided by z minus 1 by 4 plus 5 by 3 z divided by z plus 1 by 2. Okay, so that's how we are going to get h of z. Okay, later on what you are going to do here is you are going to have the inverse z transform being found. Okay, so for mod z, you will be generally taking it as mod z greater than 1 by 2. Okay, so you are taking it generally to be assuming right-handed sequence. Okay, so right-handed or positive time sequence, positive time sequence, exponential sequence to be precise, exponential sequence, positive time exponential sequence. So h of z, that would be minus 2 divided by 3, that is 1 by 4 power n u of n plus 5 by 3, that is minus 1 by 2 power n u of n. Okay, so that's how you find out h of n. Okay, sorry, this is h of n here. I think I've written it as h of z. Yeah, so taking the inverse z transform, you are finding out what is uh, h of n. So in order to find out h of n, so h of z is to be found, and h of z is got by partial fraction method, and later on you are going to find out what is h of n. Okay, so this is how you can find out the impulse response of the system. Impulse response of the system. Impulse response of the system. Okay, so this is how the procedure is all about for to find out what is the impulse response of the system. Okay, so you can have many more problems being discussed like this. Let me give a problem where a system has impulse response as impulse response h of n, that would be equal to 1 by 2 power n u of n. Determine the input of the system. Determine the input. Determine the input of the system. Determine the input of the system. Okay, if the output is given by, if the output is given by, if the output is given by y of n equals 1 by 3 u of n, okay, 1/3 of u of n plus 2 by 3 minus 1 by 2 power n u of n. So this is how you can find out what is the input. Okay, so you have to determine the input here. So determine the input of the system if the output is given by this one. Okay, so I can give you a hint. Okay, I can give you a hint where you can find out y of z. Okay, later on you can find out h of z. Okay, so in order to find out x of z, x of z is the unknown here. So from x of z you are finding out the input by inverse z transform. Okay, so from x of z you are finding out what is x of n, that is nothing but the input. So y of z is there. Okay, h of z is there. H of z, that would be equal to output, that is y of z divided by x of z. So x of z is to be found out where you will be getting it as y of z divided by h of z. Okay, so this is how you can find out x of z equals y of z is to be found out easily. It is quite easy to find out y of z, and h of z you can generally know that h of z you can find out z divided by z minus 1 by 2. It is quite clearly visible to you. You can find out what is h of z, and later on you can find out what is x of z, and from x of z do the partial fraction method, and later on you can find out what is x of n, which is nothing but the input. Okay, so this is the input. This is the input. All right, so now what you can do here is I'll give this problem to Vedant Pandit. Okay, I'll give this problem to Vedant Pandit, so he can solve it and he can share the solution with him today. Okay, so next problem what I can do here is I can have one more problem which will be discussed now. Okay, yeah, so the problem goes like this. Find the transfer function. Find the transfer function and the impulse response of the system. And the impulse response of the system. Impulse response of the system described by the differential equation, by the difference equation. Always remember, discrete systems are characterized by difference equations. Y of n minus 1 by 2 y of n minus 1, that would be equal to 2 times x of n minus 1. Okay, so you have to do that and repeat the above problem. Repeat the above problem. Repeat the above problem by taking y of n. This is the fourth problem. Y of n minus 1 by 4 y of n minus 1 minus 3 by 8 y of n minus 2, that would be equal to minus x of n plus 2 times x of n minus 1. Okay, so this two problems I can give it to KV Shashank Gowda, and this one I can give it to Vinod K. Okay, so these are the problems which you can solve it on your own. Okay, you can solve it and you can quite easily get the solution. You can get the transfer function and also the impulse response of the system, and it is quite clearly explained in the video what I've taken it today, and you can find out easily. Okay, so it is all the problems are quite easy in Z transform, that is finding out the Z transform. If you know the basics quite clearly, so it would be easy for every one of us to have the solution being done quickly. Okay, so let me stop here.